Welcome back for lesson 29-1, day 2, where we're going to be multiplying and dividing rational expressions today. So make sure you have the note sheet that goes along with this lesson that I attached in Google Classroom, something to write with, and maybe a calculator to help you with some factoring. Okay, so on the front side, we're going to start by multiplying rational expressions. Now, multiplying are the same steps as simplifying, but you just have more expressions, so you just have a little bit more to factor. Okay, so you're going to factor all your numerators and all your denominators. Okay, be on the lookout for those difference of squares because those will be hidden in here. Okay, but once you have everything factored, start by listing those excluded values before you cancel anything out. Okay, so looking at your denominator, that should tell you where you can get a 0 in the denominator, which again is bad, can't have zeros in the bottom. So look at your denominator before you cancel it out to help you with those excluded values. But once you have everything factored, okay, and you listed your excluded values, you can go ahead and start canceling out common factors. Remember, it has to be the entire factor that gets canceled out. But if you have the same thing on top and bottom, you just cross them off. So like in this example here, we have x minus 2's the same. We cancel them out. X plus 1's. We have another set of x plus 1's. And that looks like it's about it. So whatever you have left over in your numerator and in your denominator becomes your final answer. Okay. So I'm going to go through one problem with you, and then you guys will try the second one. So in this first problem, we're just going to go one piece at a time. It can look a little daunting at first, but just kind of go one kind of expression, and you'll get it. Okay. So let's start with the left side. On the top there, I have 2x plus 4. So I can take a 2 out from both of those expressions. And that's going to leave me with x plus 2 left over. And there's nothing else to factor there, so our numerator is done. On the bottom, we have a difference of squares, x squared minus 25. So the square root of 25 is 5. So that should factor as x plus 5, x minus 5. There we go. So now that left side is all done, fully factored. I might erase this guy. Okay, so now we're going to multiply by whatever's on the left side here, or sorry, the right side. So we have to factor each of those expressions. But again, just take it one expression at a time. That's all you can do. So the top is a trinomial. I'm going to make my x. We need factors of negative 50 that add to negative 5. So let's see, negative 10 and positive 5 should work for that. So that should factor as x minus 10 and then x plus 5. Okay. On the bottom, we do have a common factor of a 4 that we can pull out, leaving me with x squared minus 4 left over. Well, that's a difference of squares. So x squared minus 4, square root of 4 is 2. So x plus 2, x minus 2. Okay, so that's a lot of factoring for one problem. That's why I say just go one expression at a time and factor it as you go, and then you'll kind of start to see stuff will start canceling out. But before I cross anything out, make sure you do your excluded values. So looking at all your denominator expressions, anything with an x will give you an excluded value. So let's see, we can't have a negative 5 or a positive 5. Can't have a negative 2 or a positive 2. Any of those values, if I plug them in for x, will give me a 0 in the denominator, which we cannot have. Okay. But now that we got those taken care of, we can do the fun part, which is crossing out common factors. So we have an x plus 2 on top and bottom, so I'm going to cross those out. I see an x plus 5 on top and bottom, so cross those out. I see a 2 can cancel with this 4 and become a 2. And that looks like all we have in common. So let's see. What's left on top is an x minus 10. What's left on bottom is a 2 an x minus 5, and an x minus 2. Okay, so just remember, you can't cancel anything unless you're canceling out the entire expression. So like this 10 and this 5 on top and bottom can't cancel out because they're not the entire same thing. You can only cancel out entire factors. Okay, so I'm going to have you guys try the one on the right. You have two terms on the left side, 5x plus 45 divided by 5x minus 50. Multiply that by those two trinomials. So just go one piece at a time and factor it. Okay, and then state your excluded values, and then simplify it by canceling out common factors. So let's see how it goes. Okay, if you did it correctly, here is my work. So I factored out everything, 5s from the two left expressions. The trinomials should have factored this way on the two right expressions. So if you look at this, you do get a lot that cancels. The 5 should cancel. Your x plus 9s will cancel. Your x plus 1s will cancel. So final answer, you should have x minus 2 left on top and an x minus 10 left on bottom. Now my excluded values were 10, negative 9, and negative 1. Make sure you get your excluded values before you cancel them out. Okay, one last thing we have to do now is division. So dividing rational expressions is the same thing as dividing fractions. Okay, if we remember dividing fractions. So remember, when we divide fractions, we don't actually ever divide them. We keep the first fraction the same, and then we multiply by the reciprocal. And then from there, we can cancel out common factors, giving me my quotient in the end. Okay, so it's that keep, flip, change. Okay, keep, flip, multiply. However, you remembered when you divided fractions, we do the same thing when we're dividing rational expressions. Okay, so we change the division to multiplication, and we use the reciprocal of that second fraction. So the first one will always stay the same, but we flip the fraction, change it to multiplication. So keep, flip, multiply. Okay, and then it's the exact same thing we just did on the front, where we factor each expression, identify the restrictions, cross out anything in common. Okay, so let's look at these expressions here. So I have 6x squared divided by 3x squared minus 27. And we're going to divide that by 2x plus 2, x squared minus 2x minus 3. Okay, so remember, for division, we don't actually divide. We're going to keep the first fraction the same. We're going to change this to multiplication and then use the reciprocal of the second fraction. So I just flip the order around here. Okay, now everything else is the exact same thing we just did on the front side. Now the first expression will stay the 6x squared. Nothing really to factor there. I'm just going to keep that, 6x squared. Now on the bottom, we can take out a 3, which will then leave me with x squared minus 9, which is a difference of squares. So that's 3, how about that? Square root of 9 is 3, so x plus 3, x minus 3. And we're going to multiply, and I'm going to go ahead and factor that right side. Now on the top there, I have a trinomial, so let's make our x. So factors of negative 3 that add to a negative 2 should be negative 3 and positive 1. So that'll factor as x minus 3, x plus 1. On the bottom, 2x plus 2, I can factor a 2 out of those, leaving me with x plus 1 left over. So there's everything factored. So again, the 6x squared didn't factor at all, so it just stayed the same. On the bottom, I factored out that 3, which left me with x squared minus 9, which is a difference of squares. Trinomial on top, just a GCF on the bottom. Now, before I cancel anything out, let's do our restricted values. So anything with an x will give you a restricted value. So we have -3, +3, and -1. Any of those values, if I plugged them in, would give me a 0 in the bottom, which we do not want. Okay, now let's cancel out what we have in common. I see x plus 1s on top and bottom. Cross those out. X minus 3s on top and bottom. Now look at our values here. If I have a 3 times 2, that's 6, right? So 3 times 2, that's 6. Cancels with the 6 that's on top. So all I have left in my numerator is, looks like x squared. All I have left in my denominator is x plus 3. And again, you can't cancel those x's at all. Okay. You just got to keep them the same. You can only cancel the x plus 3 if you had another x plus 3 on top, which we did not. Okay. So I'm going to have you guys try one. You have a lot of factoring to do. You have a difference of squares and 2 trinomials. So we have to start by first keep, flip, multiply. So keep the first fraction the same, multiply by the reciprocal of the second fraction. So there's the setup for that one. So now factor everything you can and see what cancels out. So try the rest of this problem. Okay, if you factored everything correctly, you should have a difference of squares, x plus 6, x minus 6. The x minus 1 does not factor at all, so you didn't do anything with that. Your 2 trinomials on top and bottom. So now that we have everything factored, you should be able to cancel out anything in common. So it looks like that's about it. So you should have been left with x minus 6 and x plus 5 on top with x minus 5 on bottom. And there's your excluded values that I got before I canceled anything out. Okay, so again, multiplying and dividing, it's all just factoring, okay, canceling out common factors. You just have more expressions now. The only thing that's different with dividing is you have to keep, flip, multiply. So just make sure you always multiply by the reciprocal.